Okay, so this is our second class. What we did is we got a little bit started with the material. And what I tried to do is talk mostly about the website and how things will work. And so what I want to do is go over to our website. So this is XYZ homework. I'm hoping you can see it. If at any point in time, I'm thinking you can see it, but you can't, then speak up, and you'll probably have to take the mute button off so that I can hear you. But this is XYZ homework. And when you go to this website, you'll register as a new student. The course ID is this one up here, 081Sept29. And then you can register and be part of this. And so what we have here is the syllabus, information about getting access to the ebook, and the link, which you probably already know about if you're here. And class recordings I'll put here. So this one was Monday, and so that should be ready to go. And so this is the calendar. This is where we are, Wednesday, the 29th. And so the first chapter, 1.1 to 1.6, is due Friday at basically midnight. And so to do the homework so that I can see that you did it, if you scroll on down, this is chapter 1. There's the ebook. There's a video which explains it in case you need some explanation that way. But this button right here, I hope you can see it, the 1.1, this will take you to the homework. And so this way, if you do these, then I can see it's all done. Okay, so homework would be done online. Now, you don't have to purchase access for about a week or two. Once you get in, chapter 1, there's no cost to it, and so you can get started, but eventually you'll need to purchase access. And so all that information was at the top of this website. And so literally you'll just click on a problem and type in the answers, and then click on the next and just go on through. Does that, any question about that? So that's how we'll do homework. And then you can write it out on paper if you want to, but this, you'd put your answers here, and then you'll get used to seeing how they want things written, so that if you don't write it in the exact right form, they'll, tell you, and then you'll be able to fix it. And so that's what that's about. And so, for instance, question number 6, 1, 2, 3, and so on. This is the counting numbers, and I think I mentioned that on Monday. Whereas number 7, 0, 1, 2, 3, and so on, is called the whole numbers. And so that's the kind of answer you'd put in there and get credit for that. And so anyway, that's what that's about. When the class is over, if you have individual questions, you can just stay when everybody else leaves, and we'll go through any little bit that you need to make sure you're all set. So I did notice some people just kind of finished chapter 1. Some people, it didn't look like they got started. And so we'll just have to sort this out, but we're trying to get everybody acclimated as soon as we can. Now, did anybody run into questions about the first, let's say, 3 sections? Anything that you can think of? I have some topics that I thought I could discuss, but if somebody had one particular question, they can explain it to me and I'll go ahead and do it for you.
I have a question. Do I have to finish all the 4 chapters on Friday?
What we're looking for is 1.1 to 1.6 according to the calendar.
Oh,
And
okay.
so this is when they're due, so Friday night. And so
Got it.
that's what we'd like you to do by then. Now, there is a way to do a late pass, which gives you an extra 2 days. And so if you can't quite finish, then you can click on the late pass option and get some extra time.
Gotcha.
Okay?
Yes.
So anything else about the material?
Let's see here. Oh, it looks like you guys can hear me. I had a question about the sum thing. It was where's my work?
Okay.
I was curious, like some of it was like A plus B is the sum, but then the questions were like find the sum, and it was like, 7 plus 6.
Okay. I know where you're at.
Okay.
So there's several, I think, and so was find the sum of 7 and 6. So there's a couple of things they could ask you to do. One would be this. Well, that's pretty obvious what they're asking you to do. But
Right.
another thing is find the sum of 7 and 6. And you're saying, well, I'd be glad to do it if you just tell me what to do. Well, this is telling you what to do. The sum translates into addition. And so we're going to use different words for add, subtract, multiply, and divide. And so the sum always translates into addition. So it's just really this. Okay.
So it's asking for the whole equation then.
It's asking for the answer.
Okay.
It's actually telling you what to do.
Okay.
This is instruction about addition.
Okay.
Okay.
So I would show the whole work. I would do 7 plus 6 equals 13 would be the answer.
Well, I would say if it's in the homework, I suspect they're all only looking for this.
Okay. Okay.
Because this is what you're going to do yourself, but this is what they're looking for, that you actually landed correctly.
Right. Okay.
Mm-hmm. Now, the other thing is every single one, if it's adding, you're using this symbol. If it's subtracting, they use this symbol. So let's just do this one. So if they turn it into words, it's like I got carried away there. Find the difference of 10 and 7. So this is the exact same thing as up here. Difference translates into subtract. So this is what I do when I take a math course. And I've taken so many that I'm not sure how many I took. But when I would take a math course, what I would do is have a page of just a single sheet of paper, and I'd write down every definition like this, that I didn't know. And then I could find it. It's not like I had 25 pages of notes. I had a single page with just these critical things that might throw me off. And so this really translates, find the difference is asking you to subtract. And so what answer would they want? Well, they would want the answer 3. Okay. So Jackie, hi. Oh, I can see it now. Thank you for doing that.
No problem.
I got a little icon that said Jackie raised her hand. How cute. Okay, Jackie.
So you were saying, like, I have written down the words, and some of them I wasn't sure of, like inspection and 0. Like, are those words that we would need to know, like sum and difference?
Yes, no, I'm not going to ask you to like test you. Well, what's the definition of sum? But on the other hand, the the question may see, find the sum. And so you want to have a page of words. This is translation, and translation is hard. And I know some people are from different countries. No, the translation here is from English to math. English is a language, and so is math. And so you've got to get from one to the other. That's why sometimes word problems are hard, because people can't translate. And so that's why we're making a list. So while I'm at it, did I answer your question?
Well, I like those specific ones. I really didn't know if I needed to know.
I would just
like
make
it said- it said,
Yeah,
like, I don't know why it would want us to know how to define zero, I guess is my question.
define zero. I think it may have to do with division by zero. Did you get that far?
No, I just got to the definitions.
Oh, okay. Well, that I could call it something like additive identity or something. The main part about a zero. Now, this is one way they would show it to you. And what this really means is when you add zero to any old number, what you get is any old number. Now, the reason this might not make good sense is because this is not concrete. So if I did it like this is concrete. I take a 5, I add 0. What do I get? The same thing, the identical thing I started with. This is abstract. So this worked for any darn number I could think of. Adding 0 gives you the same thing. Now, frankly, I find that people have better luck understanding this and then realizing it doesn't matter if it's a 5 or a 7 or a 12 or whatever. Does that help?
Yes, thank you.
So this is that. And so I know there was a whole bunch. In fact, I mentioned them. Let me see. Here's another one that has to do with addition, which is in the beginning. They say, well, if you add 2 numbers, the order doesn't matter, right? Get you the same answer. Now that's helpful. And see, they want to know, see, I know a lot of tricks. And what you want to know is some of them, definitely some of the tricks. This, it doesn't work in subtraction, but it definitely works in addition. And this is called the commutative. Now I'm going to tell you how to remember it. Commutative property of addition. If you're at home and you go to work, this is work, by the way. You go here, and then most likely you come back home. Back and forth, commuting. Commutative, same word. This is an adjective. That's another one. I'm not so great at English. So, but this, does this see back and forth, back and forth? So that makes it easy to remember that. Commutative, commute. There's another one when you're adding 3 numbers at once. And I'm going to go 2 plus 3 plus 5. If you think you can add 3 numbers at the same exact time, you're mistaken. You can add 2 at a time and then add the third one. So the first thing I'm going to do is put parentheses around these 2 and add them. And then finally, I'll add the 5 at the end, and my answer is 10. But you know what? Taking the same 3 numbers in the same order, by the way, I could choose to add these 2 first. So 3 and 5 is 8. And then the 2 at the front becomes 10. This one is called associative, and I'll tell you how to remember that. Property of addition. I'm just abbreviating here. Who you associate is who's in your group. And so I grouped the 2 and 3 together. And then I changed my mind. I grouped the 3 and 5 together. This is who you associate with. You have friends. I'll be friends with 5. No, I'll be friends with 2. And so that's how to distinguish between the 2. Now this works from addition. You can't be doing this for subtraction, but you can do it for addition. And so people do this all the time. 5 and 3 and 8 and 2 and 5. If somebody said you had to add all those numbers, you're using these 2 properties to make your life simpler. I'm not going to start at the top and go down. No, no, no. I'm going to put the 5 and 5 together, make 10. I'm going to put the 8 and 2 together and make 20. See what I'm doing? I'm grouping things to suit me. And then I've got 23. Now, why would I do that? Well, 1, because I'm slightly lazy. 2, because the fewer things I have to do, the better chance I have of getting it right. That's my goal. I don't want to mess it up. Okay? Does that make sense to you? So these are using these properties. You can add them in a different order. You can turn them around. You can group them. And so that's the advantage of associative and commutative. And so I just wanted to say they're not just trying to, make you miserable. They're trying to make things easier for you. Okay. Other questions? Does somebody have something else that came up? I'll just keep continuing on, but if anybody has a particular problem, but I would have a page that said sum and an example, difference and an example. The next section, the key thing is about rounding. And I'm going to do this one. Round to the nearest 10th, the tens. So this is the ones place and this is the tens place. So this is a critical one right here, the 4. I kind of do this. I make up stuff, by the way. And so the question becomes, does it stay 4 or does it go up 1? Now the decision maker is here. So when this is 5 or more, this is the definition in the book, this goes up 1. So the 4 becomes a 5. This has to go to 0 and this just stays 3. But if you look at what really happened, I'm going to just, here's 40 and here's 50. What they're asking you to do, 345, which is the closest to the nearest 10. And so the rule is in the book, when it's 5 or more, you go up. And so that would take you up to 50. So this 4 becomes a 5, this goes to 0. And that just stays 3. Any question about that? There are other rules for rounding. Some places round up all the time. If it's a little bit, it goes up. But in this particular book, this rule of rounding basically uses 5 or more, go up. So if it was 342, and that's the place in question, the 2 doesn't bring it up. So this would be 340. Anybody need another example or do you think that's good?
Can you do a larger number?
Okay, why don't you pick the number for me? I'll be happy to do your problem.
3,450.
Okay, and we're going to round it to the nearest what?
10.
Well, it's already rounded to the nearest 10.
I
See,
just want to know what the, where's
let's
the,
round to the nearest 100.
okay.
Okay. So this is the 100, the
Oh,
ones, the tens, and the hundreds. The reason I kind of box off this, and I've never seen this anywhere, it's just my own little thing, is a reminder that from here, from this box, these will be zeros.
mm,
But the 5 makes this go up 1. So the 4 becomes a 5. We still have 2. And we still need to put in the zeros so that this is still reading 2,500.
yeah.
Want
Yeah,
to do
because-
another, or you think you've got it?
I used to read from left to right.
I
But it-
know, I've had students like that, and so this is so annoying.
Yeah, that's what
No,
I
I
was
understand. And so that's, I guess that's, it's just getting used to something
different.
different. Okay.
Yeah, thank you.
All right, anybody else? So that was rounding. Subtract 3 from 10. Now, this is translation again. This is slightly different. What is the actual problem? What goes first? It's subtract. And what goes second?
10 minus 3.
It is. And this expression, extract, subtract from, you're taking 3 away from this number. So the order is reversed. It's 10 minus 3. So you would get 7. So I just wanted to bring that up. Most of the time, when you have the two numbers, you just use the number. The first number is first and the second number is second. But subtracting from, you're taking 3 away from 10. That's what we need. And just pipe up if you don't like it. I want to do multiplication, and this is the 4th section. If they want to use a word, they're going to use the word product. So find the product of 3 and 7. And you say, I'd be happy to if you just tell me what to do. And that told you what to do. Product is multiply. So we're going to go 3 times 7 is 21. So somebody asked about using calculators. I think as much as possible, don't, so that you can get all these multiplication facts back in your short-term memory. I think you'll be happier that way. You'll catch your mistakes better that way. There are 4 ways to show multiplication as a symbol. Can anybody tell me any of the ways?
That in the middle.
A dot. Okay, so I'm going to go 3 and 7. So this is called a raised dot because it's not at the bottom like a decimal point. It's halfway up. And so this is a raised dot. That's clearly multiplication. Can anybody give me, I told you there was 4. I need 3 more.
Put those,
Parent-
no, they're like quotes around them, or the little curves around.
Parentheses.
Parentheses. Yes. So it could have it like that. So that would be, or like that. Or even the first one, that this would be kind of odd, but so these are all, this is parentheses. That means multiply. What else? What was the first one you learned?
X.
That's right. And the trouble with is that we're all going to eventually do algebra, and the favorite letter in algebra is X, and we don't get things confused. So this one is used the least, although that was the one you first learned. But X is the favorite letter because when algebra was invented, they used X. And they kept using it and using it for 2,000 years. So there's one more. Can anybody help me figure out what it is?
Is it a star?
Well, they do that on the computer, but just because they don't have a raised dot. But you're right about the star. The star is used sometimes. But there's something you may not think of. It has to do when you have a letter and a number. So if you
Oh, yeah.
have.
When you put them next to each other.
That's exactly right. This is the fourth way, and this is like leading us into algebra. This A is not really a letter. It's a number in disguise. And so that's a number, and absolutely there's nothing here. If you see
But-
something, you're seeing things.
You can't do that with two numbers though.
You can't. And so if you have 3 and 7, people would misunderstand it as 37. Is that okay? So when you have two numbers, you've got to use the dot or the parentheses, or, once in a while this, but I kind of avoid it. And so that would not work. But with a letter, or for instance, 2, this is a number, this is a number, this would signify multiplication. So I just want you to be familiar with, probably we'll be using the first 2 the most. Okay.
Yep.
4 things. So there you go. Plus the star. Good job for thinking of something basically on a computer. Now, let's see. Wow. Okay, what else? The other thing I want you to, I'll use the X just to show it that I can. Sometimes multiplication can be done easily. And in this case, when you multiply by 10 or 100 or 1,000, you can do it easily. And so it's 14 times 1 is 14 with 2 zeros. Do you do it like that? Let me do another one. 30 times 500. If you do this out the long way with all those zeros swimming around, you could lose it. So the zeros are a good thing. So this is what I'm going to do. 3 times 5 is 15. And then I have 1, 2, 3 zeros. So there are some good shortcuts. Does you see how that, see, I'm trying to save myself. Is that okay with you that I save myself?
Yeah.
I want to save you too. Well, okay. Anyway, that's that. So I don't know, did anybody have trouble with multiplication of like a couple of numbers? Like that? Any trouble with that? Somebody said they like calculators, and I understand why. But once in a while, they're going to ask you to do this. Hi there. Go ahead. I don't know. Sahara?
Sorry, I was just saying that I had trouble with problems like that.
Do you? Okay. So what happens is you start out with this much of it. 8 times 35. Okay. So try to ignore the 2. Can you ignore it? If you can't ignore it, I'll make it go away. So what you do is 8 times 5 is 40. And I put the 0 down and I carry the 4. And then again, I'm ignoring the 2. 8 times 3 is 24. And then 4 would be 28. Okay. So that was just, if that was the problem, I'd be done. But now I have a 2. And so now I ignore the 8. And I've got to start here because this is one place over. So it's 2 times 5 is 10. 1 left over. And 2 times 3 is 6. And the 1 left over, that's why I mark it. 6 plus 1 is 7. I then add it up. And so everything has to be in the right column. So 0 and nothing is 0. 8 and 0 is 8. And 2 and 7 is 9. Did that help? Are you
Yep, that
still-
helped.
Yeah, so just basically treat it as 2 separate problems. First, you're dealing with the 8. And if you need to do some work on the side, that's okay, but keep this part neat so you can track it. And then when it's 2, it's really 20. So you're really over on this position. And then you just 2 times 5, 2 times 3.
Hmm.
And I like a little carryover so that I don't have to hold it in my head, but maybe you can do it in your head. I don't know. Anything else? Oh, that's better.
You always multiply from right to left on that one. Huh?
Yeah. Yeah, you're going to have to be apps because, yeah. Does that help?
Yes.
And I can do more. Just tell me if you want more. And let me see what else. There's a couple of geometry problems. And this comes out a lot of times. This has to do with both adding and multiplying. So this is not a beautiful picture, but I did my best. This is a rectangle. And a rectangle, I think I mentioned it on Monday, the opposite sides are the same length. So if this was 8, let's call it inches, this would have to be 8 inches. Once you know it's a rectangle, and this was not that beautifully drawn, but that's the idea. If this was 5 inches, and it's a rectangle, this would have to be 5 inches. Now there's 2 things we can do with a nice rectangle. And one is perimeter. And I want to go over this again. Perimeter is an outside edge. So if you had to put a fence around it, or a border, or anything in a room, then you would have to, or anything that has to be around the edge. You then would have 2 of these 8s, and you'd have 2 of the 5s. Now you can actually just go 8 and 5 and 8 and 5, and nobody's going to stop you. But the formula groups it together. So there'd be 2 of the 8s, 2 of the 8s, and 2 of the 5s, which I think makes it a little bit quicker. And 2 times 8 is 16. And 2 times 5 is 10. And so we add that up now, and we're talking 26, and it was inches. Your basic formula, they call this the length, and I'll call it L. And they call this the width, and I'll call it W. So your basic formula is 2 of the lengths plus 2 of the widths. So this is a generic formula for any time you have to do it. So you just put in the numbers you have. So our thing would be, and so this would be a good thing to write on your paper if you're writing something down. It's 2. Notice the L. What's between the 2? Are you
Multiply.
seeing things yet? There's nothing there, so it's multiply. So it's 2 times, I'm talking 8, I'll actually put in the inches, plus 2 times 5 inches. So this is the formula. This is the critical step where you put the numbers into the right spot. Then you multiply first, and we'll be doing this in this last section. You multiply first, so 2 times 8 is 16 inches. And 2 times 5 inches is 10 inches. So together we're talking 26 inches. How's that? I'm going to do another problem about area. And I want you to notice that this was inches and this came out inches. So inches plus inches ends up inches. And there is an assumption that nobody, I don't ever see it in any books, that when you go to add something, they're like, these are inches and these are inches. This is not inches and meters or feet and yards or anything like that. They're the same darn thing, inches to inches. Now what I want to do is area. So here's my rectangle again. And let's say this way is 3. And let's see, 1, 2. And this way is 4. Let's do meters this time. So with area, you're always interested in how many square units you have, squares. So that's why I drew the boxes for you. 3 times 4, do you see it? It's 12 squares. So back to the formula, if this was the length and this was the width, I need to multiply 4 times 3. And I'll get 12. Don't I? I didn't say it was a beautiful picture, but there it is. So it's the length times the width. That's the formula for area. What do we use area for? Well, let's say we wanted an area rug. Or let's say we wanted to paint a room. We need the area so that we get the right amount of paint. Correct?
Mm.
Have you ever done that, painting? Oh, you'll do it before you know it. Eventually you'll be painting something, I'll tell you that. So because these two letters are next to each other, we take it as multiply, right? If you want, you can put a dot there for a reminder if you think you need it. Now, what's next?
The numbers.
Yeah. So area equals, so the length would be 4 meters. And the width would be 3 meters. So notice I use parentheses
Both.
instead of the dot. I think that kind of worked out better for me. And so what I need to do are 2 things. 4 times 3 is 12. That's my number. But here's what's different. Meter times meter is what?
Square.
What is it? I'm not adding, I'm multiplying. So meter times meter is square meter. Because we have squares, don't we? And so you would write it, sometimes you see it written out like this, square meters. But that's a lot, you know, square meters, that's all, I gotta write all that stuff. This is the shorthand way to say it. And so you still might say square meters, but it's meter squared, it's the same thing. Is that okay? So meter times meter is square meter. Okay, and everything that's area is square. It's trying to get how many squares do you need?
You don't put the square on 12, right? Because you multiply them.
Yes, literally what I did. You can see how I got the 12, but meter times meter. This is 1 meter, this is 1. It totals 2. We'll
Gotcha.
do more of this, but we keep bringing in a little geometry because it's so practical for different things. So it's square. If it's area, it's square units. And if it's perimeter, it's not square, it's just plain, just like this previous problem where it just turned out inches. The point I want to make is that to add or subtract, ready? You must have like things. This has become so important as you branch from arithmetic to algebra. Adding and subtracting requires this. And so if you don't have the same type of thing that you're trying to either add or subtract, you can't do it.
Mm.
So for instance, if I had 3 feet and 4 inches, I do not have 7 something. It seems so obvious they forget to mention it. And so if I have 3 meters and 4 meters, I am good to go because I have like things. And so that would be 7 meters. Now this becomes important as we branch into algebra. If we have 3x and 6x, you see what it's going to be? Not that you have to do this yet, but you see what I'm trying to say?
Yeah.
What is the answer going to be?
18x.
How much? Remember it's
18.
adding.
Oh,
So what would it be? 6 of these and 3 of these and 6 of these would be
9x.
9x.
oh, I see.
You don't have to grab it this first time, but I want you to see it's the same darn thing.
I was
We have
multiplying.
like things. And so this was meter and this was meter, so we could do it. But don't be trying to do something that are not matching. So that's one of the reasons where we sometimes have to make it all in inches or all in feet or all in meters so that we can actually add or subtract. There was, I want to do really fast multiplication. A times 0. This is a number, and I'm never going to tell you what it is, and it doesn't really matter, but I'm going to multiply it to 0. What's my answer?
0.
Always. And the first time I saw somebody gave a name to this rule, I was in college at age 18, and I said, the book called 0, the Multiplicative Annihilator. You like it? I've always remembered that. It was so cute because you have number, big numbers, millions, billions, billions, times 0, all gone. Okay, here's another rule. And the name of it, I don't think is so critical, although you might have to do it. I take a number and multiply by 1. What number do I get?
A.
You get the same number you started with. I did it before with like 5 times 1 is 5. A times 1 is A. This is the same exact thing. Do you remember this one? All I did was switch the order. So this is like 3 times 5 is 5 times 3. What do you think it's called? Remember the word back and forth, back and forth?
Commutative.
Commutative for multiplication. Big deal. You can do this with adding and you can do this with multiplication, but not the others. And finally, this last one, if you had 3 numbers, you could choose to multiply the first 2 at the beginning and then multiply the result to that, or you choose to multiply the back 2 and then multiply it by this number. Do you remember what this word was called when you group it? Your friends, your associates? Do you remember what it was? Associative
Like associative.
for multiplication. Is that okay? Yeah. So if they want you to multiply 3 and 5, the word they use is find the product. So the word product is a way to say, multiply, please. And so you say, all right, I'll do it. I don't want to, but I'll do it. And so product, remember it was sum for addition, difference for subtraction, product for multiplication. Okay, make a list. I want to do one more. Well, I don't know. I can never stop talking. Division. Keyword is quotient. Find the quotient of 10 and 2. Quotients is telling you to divide. Divide 10 by 2. Now there's several ways to show division. So can anybody come up with any little way? You're doing a line.
Wait, yeah, the line thing.
Yeah, so this would be one way where it's horizontal. Sometimes when you use your computer or something, you have to use this symbol, but that's the same real thing. The first number is on top, the second number. So 10 divided by 2. Answer, of course, is 5. Does anybody know another symbol that would work for division?
The half box.
Oh, the box, like this? That one?
No, but that's good.
Oh, I know what you're gonna do, like that.
Yes,
So where does the 10 go and where does the 2 go with this setup?
the 10 inside and the 2 upside.
That's right. So this is 10 divided by 2. And this is the other symbol that has been used. So that's 10 divided by 2. Okay, so you can see it this way or that way. And so those are all division. And the word, if they use a word, they might use quotient. They might say divide, which is pretty obvious, but quotient would be the word that you may not know. Do you remember whole numbers? I'm going to abbreviate, and counting numbers. Can anybody recall the list for each of these?
For whole numbers, doesn't it start with 0?
The whole number starts with 0 and then goes up. We're not into fractions yet. And then 3 dots means, the symbol means keep on going in the same pattern, which means you're going to go for a long while, right? And then counting numbers, what would they be?
1, 2, 3.
1, 2, 3, okay. And then I'm going to put 3 dots. You can't just put one number because you have to do enough so you can see the pattern. But here's the deal about division. 0 can be a problem. And so what I want to do is give you a bunch of problems. 7 divided by 7, 0 divided by 7, 7 divided by 0, 0 divided by 0. Well, can you give me the answer to any of these?
0 divided by 7 is 7.
No, that's not.
No,
gonna work.
0.
It is 0. This one is 0.
Oh,
The first one is 1.
Yes, typically the same number divided by the same number is 1.
That's
There's a
zero.
problem here.
So the third one is 7?
The problem ones are here. Does anybody know how to, what happens on this with these?
Zero, is it just zero divided by zeros?
No, that's not the case.
I don't know.
Did anybody know? It's a fancy word.
Oh,
These are
undefined.
undefined. That means they have no answer no matter how long you try. So I want to show you really quickly where this comes about. If I have 3 times 5 is 15. So 15 divided by 3 would be 5. Can you buy that? 15 divided by 3 is 5. And it's because of the multiplication fact, 3 times 5 is 15. So the division problem and the multiplication problem are tied at the hip. And so you can't have one without the other. This one means this one has an answer because this one has an answer. Now, when you had 0 divided by 7, the correct answer was 0. And I want you to follow the pattern because 7 times 0 comes back to that original number 0. Just like 3 times 5 comes back to 15. Okay? But now let's do a funny one. 5 divided by 0. I say the answer is 17. Okay? You're going to play along with this?
Okay.
If that was the correct answer, then this times this would give me that. Well, it doesn't, does it? What about 0? What if I said, okay, I gave up on 17. I say the answer now is 0. That would mean 0 times 0 would be 5. Is that true? Not true. In fact, there's absolutely no number I can put in here to make it come out 5 because the first number was 0. And so it's never going to be 5. I'm going to do 17 again because I like that number. If this was the correct answer, then this one times this one. Oh, it's right. 0, this one, times 17 comes back to 0. So I was correct. The problem is any number I had picked would have been good. 5 would have been good. 12 would have been good. 10 would have been good. Every single number in the world would have worked. In the first case, absolutely no number worked. In the second case, every single number in the world worked. How do we feel about things like that? We don't like it. Because in math, if you had every single answer in the world correct, what a mess we'd have. And if you have no numbers, it would still be a mess. Okay? Hey, Zach, can we have your face? Oh, okay. There you go. All right, how's that? Here's how to remember it. If you didn't like my explanation, I hope you halfway liked it. Some student gave me this. This is a division problem. This n is for any number, and this is a 0. And if you have any number over 0, it's no. You can't do it. Do you like it? Can you remember it? So when we have 5 divided by 0, are you going to give us an answer? That's a no. And if you have to come up with the correct word, it's undefined. So this is why there's the distinction between counting numbers and whole numbers, because you can't do this. Now, I don't know if anybody liked watching Star Trek, the original. Anybody into that? It's my age, I guess. So Spock, there was a spaceship and there was an alien being that got into the computer and it was going to turn off the oxygen. Ready for this? What did Spock do, being a smart mathematician? He put in a problem into the computer like this. And what the computer would do is try forever, trying to come up with an answer. Well, guess what? You're never going to get there. So you try and try forever. So we put in an impossible problem into the computer. And guess what? That alien being left. It was so upset. Don't you like it? So that was the problem they put in, because it's an impossible problem. Okay, it's impossible. It tries to go to, actually what it tries to do is go to infinity, which you can't ever get there. And so forget it. Okay. So it's now 11:30. So I think what we'll do is next Monday, we will go ahead and do work on that 1.7, which is order of operation. Some people may be able to do it without assistance. Let me see. There was people chatting. Let's see. I have to be here. Yeah, thanks. Okay, let's see who else. Yes. Okay, people. Somebody asked, I think it must have had to do with rounding. Jordan, are you still here? It looks like a 1.5. What about it? Are you still here? I don't see you. Okay.
I don't see it. Oh, Jordan.
Jordan, oh, okay. Yeah, you sent me a message. 1.5 was a struggle. Do you remember what a problem? See, if you would write down a specific problem, then I could do it on paper and show you how I would do it. 1.5. Oh, I know. There was one more section. I could do it really fast. One of the topics in this had went like this. They called this might have been it. That was in my notes, the distributive property. Now, most likely what a person would do is, because of the parentheses, they might do that first. And so 5 and 6 makes 11. And then you still have the 3 outside. And then 3 times 11 would be 33. Okay, so that's how you might do it. But another way to do it is this, and it's called distributive because this one goes to the 5 and this one goes to the 6. So somebody taught me to do these little lines, and so that's what I do. So it goes 3 times 5. 3 times 5, I'm just going to write the answer is 15. And then 3 times 6 is 18. And finally, 15 and 18 turn out to be the same exact number. So if you can do it the easy way for this distributive property, then you probably should. But the distributive property works sometimes in this case, and I'll show you. Remember, this is a number that we haven't said what it is yet, and so maybe we'll never do it. But that's a number. Don't think of it as a letter, it's a number, really. I don't know what it is. And so I can't add it to 5 because I can't tell if they're like. So I'm restricted from adding them. So what I do is this. This is 3 times x. How could I write that?
3x.
3x. Then I put my plus symbol in. Plus 3 times 5.
15.
15. So knowing that this property, distributive property, works allows me to simplify a problem when I can't do it the easy way. I can't add x, I have no idea what that is, that number, to 5. So I have to distribute. And so that's what we might do. It might prove helpful in other ways, but in general, it also works for subtraction. So this is 4, right? And then 5 parentheses means times 4 would be 20. This is 4, this is 5. 5 times 4 is 20. But to convince yourself that it works with the other way, 5 times 10, remember that's an easy one, is 50. Then the minus 5 times 6,
30.
30. 50 take away 30 is still 20. So sometimes we need to convince ourselves that's going to work. And so again, it's like a shortcut. Okay. Now, so do you know what you need to do? This is Wednesday. You have till Friday to finish 1.1 to 1.6. You can watch videos. You can send me an email if you need help or whatever. And then we'll be back on Monday and we'll complete that. So I'm going to stop the class. Let me see. Let me get back.